Mm, Done. Okay. Well, welcome, Professor. We are thrilled to have you at our university. I will deliver some welcoming remarks, and then I'll hand it over to you. You'll have about 40 minutes for your lecture, followed by 20 minutes of Q&A. And well, the University of Chihuahua, through the Faculty of Engineering, is honored to continue this cycle of conferences of the National Network of Water Postgraduate Programs. This is an initiative by the university to invite national and international researchers who study water related issues to engage with our postgraduate students. Today, we continue this cycle of conference with a presentation by Dr. John Hawley. Dr. John needs no introduction. He has been working in topics related to hydrogeology of arid basins, stream aquifer interactions, isotope and trace element hydrochemistry, and hydrology of urban areas. Today, he will deliver the lecture entitled The Hydrologic Framework of the El Paso del Norte Borderlands region. The floor is yours, Professor. Welcome to our university.
Okay, so yeah, there we go. I think it just. Let me hide this little thing here. Good morning. Thank you very much for inviting me to speak to you today. I'm my colleague of many years, Baird Swanson of Swanson Geoscience, is here with me. He prepared many of the illustrations that we will be seeing this morning, and the other co-author is Steve Walker, who is right now is a GIS cartographic specialist and electronic database and hydrogeologist now with the city of Santa Fe, New Mexico. And our other co-author, this is on the original report that I'm going to be referencing, is called a hydrogeologic framework of the Mesilla Basin region of New Mexico, Texas, and Chihuahua. And I've been working on this. Being a geologist, it's very slow work. And so I've been working on advances in conceptual and digital model development way back. I started in Nevada in the 1950s, and geology, as you know, is an iterative thing. It's like Groundhog Day. You wake up each morning and you have to do it over again, and but you gradually progress. The area we are going to be covering today is the southwest part of New Mexico and adjacent parts of Chihuahua and the state of Texas over here, east of El Paso and Ciudad Juarez. The area of main interest is outlined in magenta, or in this black square, and we will be talking about that is the New Mexico Water Resources Research Institute study area. And like I said, I started this when I was with the U.S. Soil Conservation Service in 1964, and then we joined in with the part of the study in Chihuahua, we joined forces with the colleagues in the Secretary de Cursos Hidráulicos, now part of Conagua in Mexico, back in '67. And I've been working on it ever since. And I've had some cancer problems and things like that that keep slowing me down, but we are trying to finish our work in the next year. In this one slide, there's a large area that includes the what is called the Acuífero Conejos Mendos in the northern part, and the whole area that is outlined in gray here is called the Zona Hidrogeologica Conejos Mendos. And I'll where these names come from, I'll explain. But these outlines are from an INEGI report that was published in 2012. This long feature here is a rift basin, Rio Grande rift basin, a kind of a pull-apart basin that's superimposed on a earlier laramide or early tertiary tectonic feature of compressional origin, which is called the Chihuahua Trough. And so you'll notice that features, large topographic tectonic features have a north-south trend north of the international boundary. And then when they south of the about 32 degrees longitude, everything shifts to the southeast. The Rio Grande, Rio Bravo has a north-south component here, and then one between here and the Big Bend area of Coahuila and southern southern Texas, Big Bend area has a northwest southeast trend.
Excuse me, forgive the interruption. Are you seeing his cursor showing up on the screen when he's pointing?
No, we can see this.
How about over here?
Done. Yes, we can see it.
Okay, well, the lineation he's talking about is the north-south trending that's north of the border. And then you can see from about the 32-degree parallel this turn where both sides of the basin have turned with the Texas lineament. And I wanted to show that and make sure the cursor was showing on the right screen.
Okay.
Yeah. Okay, thank you. Perfecto.
Okay. The next slide is the details of the New Mexico Water Resources Research Institute study area. And to the south is that line that I'm following along here is the alignment of Mexico Federal Highway 2. And it starts over here in just south edge of Ciudad Juarez, and then goes in a more or less west to southwest trending area or trending alignment over to the mouth of the Rio Casas Grandes, which we'll see. And we will talk about these lines that show these are locations for hydrogeologic cross sections that we've been developing over many years that show in detail the hydrogeologic features down to mean sea level. And then later in the talk, we'll talk about the deeper geologic units in more schematic block diagrams that are and cross sections that show there's less detailed images of the Earth's crust to about 5 or 6 kilometers below sea level. This is a large Google image that bared a fairly recent Google image about, in this case, about 2017, and which shows Paso del Norte is right here where the cursor is. And you'll see these red lines. They are the main lines of channel belts, of channels of the ancient Pleistocene Rio Grande. So in this case, about 5 million years ago, the Rio Grande and the River Bravo flowed into a series of endorheic or internally drained basins that had a large lake, that Paleo Lake, which we name in honor of Alvar Nunez Cabeza de Vaca, the first Spaniard who traveled across this area between 1528 and 1536. He went through this area, he and a party of 3 companions who had been shipwrecked off the Galveston coast of Texas, and then they ended up in the near Guaymas in the Baja California or Sea Cortez area in 1836. And he wrote a very detailed account of his travels across here. But of course, he had he describes this very large inland sea, which would be maybe the size of Lake Michigan or Lake Huron, Lake Superior, and one of the large lakes in the United States, or the large dry lakes of the Southwest, which like Lake Bonneville or Lake Lahontan in the Great Basin area of the United States, or the in Cuatro Ciénegas in Coahuila, or the Bolson de Mapimí in farther south in Mexico. And this was when there was enough water during winter times in the watershed, a large lake would form, or femoral lakes, and the magenta lines show the distal part of the Rio Casas Grandes. The lighter red are the lighter lines, still magenta color, are the Rio Santa Maria. And then over here in the more orange colors is the Rio Carmen. And these 3 rivers have their sources, of course, in the Sierra Madre Occidental. And then the yellow is a river that heads in New Mexico in the Mimbres and the Black Range Mountains that is the Rio Mimbres, and it enters the basin, the ancient basin of about in the area near Puerto Palomas or Columbus, New Mexico. Then the Rio Grande has headwaters back in the southern Rocky Mountains of southern Colorado and New Mexico. And then and that system all ultimately drained out through the Big Bend area and would have joined with an ancestral Rio Conchos in near Ojinaga in Chihuahua. And then there are other basins that come in from the north. But what happened between 5 million years ago and about 500 or 600,000 years ago, it deposited a huge complex of sediments that we include in the Santa Fe group that filled the Rio Grande Rift basins of this part of the South American Southwest. And that unit covers everything. It's only been removed in the valleys of the Rio Grande, Rio Bravo, in a very narrow valley. And most of the places, these deposits are still part of the major basin fill deposits and constitute the most productive aquifer systems in the region. I'll show you a couple of slides just very quickly of what this material looks like. Oh,
Hit the button again. There.
Okay. I have to keep moving. There's a lot of material in here. This is a 300-meter section that's exposed just northwest of Las Cruces, where they showing a coarser phase. There's a Piedmont or alluvial fan material coming off a mountain range in the first 100 meters, and then below that, for maybe exposed, another 200, another 30 meters up at the top, and another 60 meters below that is just basically sand and pebbly sand, with most of the coarser pebbles well-rounded that are derived from a river that headed in northern New Mexico. Downstream, across from about 30 kilometers south, 20 to 30 kilometers southeast of El Paso, and across from near Fabens, Texas, you have, or McNairy, Texas, you have the distal part of that unit, and it's finer grained. And in that area, there's a very thick ash bed, volcanic ash bed that was erupted in the Yellowstone volcanic area about 2.1 million years ago. So that's kind of showing from north to south what it is. Most of the section down in the southern Waco Basin is in the deep subsurface. Then finally, over at the mouth of the Rio Casas Grandes, near Sais de Enero or Los Trios, at the junction of New Mexico Federal Highway 2 and the Puerto Palomas Highway, we have another thick deposit. This is my friend Alfredo Granados, and one of his colleagues from the Casas Grandes, lower Casas Grandes Valley. And I'm sitting here trying to look for scale. And but this is the, and then there's a very thick caliche type or calcareous soil that caps it, indicating that these deposits are probably 500 to a million years old, 500,000 to a million years old, or a little bit older. Then they're sitting on some lacustrian beds that are interbedded in the distal part of these. These would be beds of the Lake Paleo Lake Alvar Cabeza de Vaca. Uh, this is a map of the area, just the Borderlands area. Here's Paso del Norte, El Paso, Ciudad Juarez, and the international boundary going west at and the Mimbres Basin, the Rio Grande, the deep valley of the Rio Grande, which becomes the Rio Bravo at the international boundary going down to the Hueco Bolson. We have a remnant of a much younger lake that once the valley, Rio Grande Valley, started to cut, it drained. It became, went from being endorheic to exorheic, and about 500,000 years ago, the Rio Grande broke through the canyons of Santa Elena Canyon and the other canyons of the Big Bend area, and flowed to the Atlantic or the Gulf of Mexico at near Matamoros, and that development of through growing drainage cut through the upper part of the Santa Fe group and drained this part of the fill. But in contrast, this area of the that makes up most of northwestern Chihuahua stayed endorheic. So it still terminated in a closed basin that was the terminus of the Rio Común that entered the basin near Villa Ahumada, the Rio Santa Maria, the Rio, which ended both in the Laguna Santa Maria and the Laguna Fresnel, and the Mimbres that came in from the north, and then the large delta a complex of the Rio Casas Grandes, that Los Trios outcrop is over in this area of that.
You're working on this slide only.
Yeah. Oh, sorry. That Los Trios area is just west of that slide. This is one of the contrasting things, once we cross the international boundary, we have a white map, or what one of my colleagues call the white. In the United States, we have our own classification, and then once we cross the border, we switch from Anglo-centric to a Mexico-centric view of the world. And so we have the Acuífero Conejos Mendoza. This is a binational waters map published by the IBWC, SILA in Mexico. And this shows the outline of the area that I will be showing. And we have a large remnant of Lake Palomas, a saline or barriel type basin that is part of a remnant of the dried up Lake Palomas. We will go through a series of what we use now to I've been talking about the cover, the frosting on the cake of of the basin fill. If we go to geophysics and look at seismic, gravity, other profiles, this is the international boundary here. El Paso del Norte is here. The Rio Bravo trend is here. And when we cross from the Sierra Sapeo, Sierra Presidio, Sierra Patrio, Sierra Samalayuca here, Sierra del Presidio here, when we do a geophysical profile across these basins,
Switch to the next one.
we see a different protection, and in this case, we get a help from a very deep borehole that was drilled by Petróleos Mexicanos, the Pemex Moyotes well exploration well, and that starts to give us a accurate more, and we see a real deep basin that was not ever identified before, that is located at under a feature, a large Rancho El Parabian, that is, and the people who did the work, Alberto Jimenez and Randy Keller of the University of Texas at El Paso. This is Dr. Jimenez's doctor's dissertation research, mainly. They named this basin the El Parabian Basin. And so most of the really good information we have on deep surface is from geophysics and a few deep drill boreholes. This is a map, a recent map of the Conejos Mendoza from here's Sierra Juarez, the Rio Bravo, Rio Grande here, the international boundary here. And this shows this is the Sierra Sapeo, Sierra Samalayuca here. And this is the name Conejos, or the jackrabbit, comes from a railroad siding on the western Chihuahua Pacifico branch from Juarez to Los Mochis, and Mednos comes from a large sand dune field here that we'll talk about in a minute. But the next slide is a cross section across this part of the basin, and this is 107-degree west latitude. This point right here. And this is, again, a cross-section from Conejos, from the Kanawha document of this part of the Mexico. And this goes from near Puerto Palomas, or just west, over to the southern end of the Hueco Bolson, east of Sierra Juarez. You'll notice here in Mexico, Kanawha calls this Bolson de Mesilla. And this little area here this is in the US, this area would be the southern end of Bolson de Mesilla. And this would be called Palomas, El Parabian Basin. So there's some, one of the big confusions is just that we run into doing transboundary work is that we change names for major features. This isn't anybody's fault. It's just that way people like me and my predecessors have done geology. This is just with the just geophysical work and everything. This is the Mesilla Basin. This is the El Parbian Basin. And you'll notice that this slide is rotated so that north is now to the left. And this is the Mesilla Basin. And we've divided the Mesilla Basin into about 15 subdivisions based on drilling, geophysics, and then we'll notice that what's called the Mesilla Basin here is separated from the El Parbian Basin by a buried bedrock high that connects a mountain range in New Mexico, the Potrillo Mountains, with the uplifted exposures of that is the Sierra Sapeo. And the orange areas and the kind of pale areas are very high. Bedrock is exposed, or this is Franklin Mountains, Juarez, Ciudad Juarez, Oregon Mountains. These are bedrock are shallowly, are exposed as highland or uplift, are very shallowly buried. This is what we've done here is take the geology. The orange colors are tertiary igneous rocks. The blue colors are carbonate bedrock. The green Paleozoic age. The yellows are carbonate rocks mainly carbonate rocks of Mesozoic age, and then the volcanic rocks of various ages. The young volcanics are in this light violet area. And then the contour lines are in meters, 5, 10, 30 meter intervals that show the general position of the potentiometric surface. So what we do when we split the basins up, we with the borehole information and everything, we first look at the textures. If it's an ancient river deposit like this unit here, or these yellow areas here, they are fluvial deposits that have a lot of sand and gravel in it. And when you get to the more greenish colors, you're going there. You are in the clays and silts, and arceo, and that kind of fine grain material that is deposited at the distal part of these fluvial systems. The purple systems are the Piedmont, the material that's shed off the mountain ranges. They are coarse grained, but they have they contain their mixtures of sand, silt, clay, and gravel. And so they're not very good aquifers. And we divide those into 10 units that are called lithofacies assemblages. And these are the subdivisions of the Santa Fe group. And then we can, using water data from drill production data from logs of well production from well fields like the Ponta de Agua well field, we can zone, we can classify these by hydraulic conductivity, bedrock configuration, and then groundwater production potential. And then we move ahead, and we can zone the information from the Santa Fe group beds. We can have a lower, middle, and upper unit. The upper unit is dominated by ancestral Rio Grande, ancestral Casas Grandes deposits. They have relatively high hydraulic conductivity and relatively good quality water. And these are cross sections. This particular cross section, for instance, is SS is long parallel or almost on top of Mexico Highway 2. Then this is a longitudinal profile that follows the deepest part of the Mesilla Basin. It comes out of a narrow canyon area at the head of the basin called Selden Canyon, and then as we go down basin, at the end at Anafra and just at Cristo Rey, it enters another narrows. This is the Paso del Norte narrows, and there are basically Cretaceous rocks, mostly carbonate, over Paleozoic rocks, blue, mostly carbonate, and there the groundwater and the surface. This little tiny line at the top is the 125-meter thick deposits of the Rio Bravo, of the Holocene, very recent Rio Bravo deposits. And then below that are the much thicker deposits of the Rio Grande and the Rio Bravo. And it goes through the river flows through the narrows here, Paso, where it's, and the groundwater in the deeper Mesilla Basin circulates upward at that, and water quality gets poorer and poorer. Then it crosses a large fault at the east edge of the Sierra Juarez and Sierra Franklin block, and then you have another thick section in the western Hueco Bolson. And then these are large intrusions. This is the Cristo Rey andesitic intrusion that is at Smelter Town in El Paso, for instance.
There you go.
Then what we do is we put together, Barrett and I, and have been putting together over the last 15 years maps of this is the Mesilla Basin, and this is the basin to the north, Jornada del Muerto, and then this is the El Parabien Basin down to Highway 2, going across the southern end. And we've in this case, we've done, because it's a New Mexico project, we do the thickness, we contour the map thickness in feet of saturated sediments. And we assign these different values of the lithofacies. 1 and 2 are very high. They get the numbers. 3 are intervented sands and clays. 4s are ancient dune deposits like the Memnos de Samlayuca analogs. And then and then other other deposits there are very, very few deposits of very fine grain. And then we go deeper into the system, into the middle Santa Fe group, and we see still it's dominated by units of three that are ancient fluvial deltaic deposits that are mainly sand and intermittent fine sand and gravel, but still have pretty good hydraulic conductivity. And then we get down, we find 10, which is a evaporite bearing clay that has very low hydraulic conductivity. And then at the bottom of the Santa Fe, 1,000 meters, sometimes below the surface, but always within over in the deeper part of the aquifer. In the lower Santa Fe, we start seeing a higher number lithofacies assemblages. And I'm covering a lot of ground here, but each one of these slides we could spend an hour on. Now I'm going to conclude with some general pictures on a larger scale. These are here we have a schematic depiction of the subcrop topography. When you take all the Santa Fe group off, this is the topography at the base of the aquifer, and the geology. This is a geologic map of what you would see if you just went through the basin fill, and what you would have. You have the older sediments of the Chihuahua Trough in some deep subsurface. You have some intrusive areas of middle Santa Fe group, or just middle tertiary monzonitic, very varied mountain ranges like you would see on the Oregon Mountains, of large igneous volcanic centers that are down 1,500 meters below the surface. And this is what it looks like in cross section. We've done 3 cross sections. This one is just south of the border, going through the Cerro Juarez uplift, but you'll see here, and the Hueco Bolson's over here. And the Hueco Bolson, you'll have very thick basin fill up to 2,000 meters thick in the Hueco Bolson, and maybe 1,000 meters thick in the Mesilla Bolson. And then as we go north to 30 degrees north latitude, for the middle of the Mesilla Basin, we have a still thick, very thick middle Santa Fe group, or Santa Fe group basin fill in yellow. But in this case, bedrock is 3,000 meters down below the sea level. And then as we go north in the basin, we have ranges like the Franklin Mountains that are they're mainly carbonate. And then we have mountain ranges like the Oregon Mountains that are 3,000 meters above sea level. And they're tertiary intrusive rocks of like you would have. There are some in Villa Armada, similar ranges. Then I'll close this with 3 block diagrams that with no vertical exaggeration now. Their base elevation is 7.6 kilometers below sea level, or 25,000 feet below sea level. And these are based on deep drilling, a few deep wells, and a lot of geophysics and detailed mapping where the rocks are exposed in the mountains. This is at south of 32 degrees, which is the New Mexico Texas state lines east of the Franklin Mountains in the Waco Plaza. Then we've got this is along the international boundary. And this is showing the El Paso del Norte is here. This is right along the corridor of the Borderlands. And we have a thin yellow basin fill, early tertiary sediments of the Chihuahua Trough that are in brown, and then some thinner in yellow here, some thinner Mesozoic rocks of Jurassic and Cretaceous age. And then we have Paleozoic and Precambrian basement at depth. That we're showing in the base of this, we're showing the shoreline of where the high level of pluvial Lake Palomas, when it was standing at 1,200 meters and above sea level, and about 100 meters higher than the entrenched valleys of the lower Rio Grande and the Wake and the Valle de Juarez over here, or the El Paso Valley in Texas over here. And here's the Sierra Juarez and the Sierra Sapeo. And then these blue lines show the discharge. This would be from Lake Palomas at its high stage. This would be good quality water, less than 1,000 milligrams per liter total dissolved solids. And it's flowing. And when we look at isotope data, such as the work by the PhD thesis work at New Mexico State by Ana Maria Garcia Vasquez, we're seeing that this water is very good quality, but when you look at its isotope age, it's tritium, or it's water that is moved into the area that maybe 5, 10, 20,000 years ago. And then the last slide is we're sitting now at Paso del Norte. Here's in the cross section, we're seeing the Cristo Rey intrusion. We're seeing pluvial Lake Palomas over here. We're seeing the large Junta de Agua well field, JMAS well field here that's pumping. There are 26 wells designed to pump 50 liters per second. And this is and then combined with wells in Santa Teresa area of New Mexico, this is a large water mining area. This is the dune field, the Mednos de Samayuca. And I've gone 10 minutes over my, so I apologize for going over, but I'll leave a few minutes for questions.
Well, we still have a little bit of time for Q&A. I'm going to change to Spanish. Is that okay with you guys?
Yes.
Si alguien tiene alguna duda, si alguien tiene alguna pregunta, la pueden hacer en el chat o pueden levantar la mano y sin problema yo leo acá las preguntas. Por acá dice Luis Ernesto Lesner Carrillo, sorry, I have to leave. Excellent presentation. I love the description of the outcrops. Uh, Also, just give me a minute, guys. Here, how do you imagine El Paso del Norte water supply will be like in 50 years? We can listen to you, John. Uh, you mute your. We can listen to you.
Hello.
Done.
Yeah. One of the problems is we have about 200 million people. I mean, 250, 2.5 million people, 2.5 million people in that area, and too many straws in the aquifer, and so one of the things I'm working on right now is cutting back on water for irrigation and doing more treatment of brackish water and marginal water for industrial and municipal use. And El Paso is way ahead of the game. The city, the El Paso Water Utility, has been for the last 30 years working on designing wells in the southern Waco Bowl Zone and putting in a large desalination plant. And this is the way I think I'm encouraging people to join together in the Santa Teresa, San Geronimo, the Foxconn area of Ciudad Juarez to do the same thing. They have a better aquifer, actually, and than they do in the Waco Bolson in terms of permeability and thickness. And it is recharged, has potential for recharge from the southwest, but it is from particularly the Rio Casas Grandes basin. And but it is going to be a real problem. I'm glad I'm 91 and well, Baird's young. He's only 68. And but it's something I said. I think I encourage you, all of you, to read the background papers that I sent. I sent 8 papers, and the first one is just the history of people that background paper 3, which has talks about the history of work that was predictions by particularly a Dr. Octavio Chavez and Dr. Al Utton in the United States. But Dr. Octavio Chavez, 25 years ago, wrote 2 very detailed papers predicting our present situation. And he talked about mining of shared aquifers in the Paso del Norte area and the white map syndrome, which is the lost in translation, where 2 countries are not working together. They're working separately. And this is, and the United States, to be honest, has not been a leader in binational cooperation for the last 2 presidential terms. I won't go there.
Well,
but we didn't have a wall for instance.
That that leads to the second question. It says, can you talk a little bit more about the International Transboundary Waters Treaty between Mexico and the United States?
Yeah, I've written that is in that I described what we've done in this background paper 3, and this is very important. And I one of the problems early on was that it was never fully implemented. The Transboundary Aquifer Treaty, it was signed by President Bush in December of 1990 or 2007, and he got us on started in the right direction. That treaty, it's like the La Paz Treaty of 1983, or the earlier treaty when, but I we I was supposed to get, and the Water Resources Institute were supposed to get large infusions of capital to do these studies, and all that money dried up. It never was allocated properly, and USGS has done some excellent work. The work that on isotope chemistry that has been at the Universidad Autónoma de Ciudad Juárez has been excellent, and but it's been done. I myself, I had a small consulting firm, and Barrett and I have kind of pro bono done work for the last decade. But my work has received, and the work of the excellent work that we've tried to do at the Water Resources Research Institute at New Mexico State is it's kind of and University of Texas El Paso has done great work in geophysics, but it's still not coordinated, and I'm waiting for what happens in the United States on January 20th, 2024.
25,
I have one personal story. I was working very intensively in northwestern Chihuahua with the Secretary of Recursos in between 1967 and 1969. We did a Geological Society field conference, both the University of Autónoma de Mexico, with Diego Cordova as the senior editor. We did this 3-day field trip of northern Chihuahua that I cite quite extensively. And all that on January 20th, 1969, all Americans working in Mexico that were on a federal, I worked for the U.S. Department of Agriculture at that time. We had our passports requested. We turned in our passports. We could no longer officially represent the United States and to collaborate officially in Mexico. What we did after that was the universities, your university, we all collaborated as scientists, and that's the hope of the future. If you're going to count on the American government or your government to lead the way, it's going to have to be from the bottom up. I think it's going to have to be ordinary, dedicated scientists and private industry who carry the ball. In my case, back then, President Nixon came in, and he had an issue with the Mexican government on recognition of Cuba back then. And he just said, well, we're not going to have a collaborative program. And then President Reagan brought it in again with the La Paz Agreement. Bush brought it in with the Transboundary Export Act, and then other people come in and they want to build walls and not gates. And at the same time, you have this horrendous problem of on both sides of the border. We're the biggest customer of fentanyl, and we're your customers. And so we don't. And I'm an old man. I was in the U.S. Army and in occupation of Germany back in the 50s, and
Really?
so I've traveled extensively, and so what I've tried to do is please read the background papers. I've tried to I put a lot of my life into those over the last year, and I have children and grandchildren. All my children, my three boys, a daughter, or two boys and a daughter, are all from Doñana County, New Mexico, from Las Cruces. They grew up going down to Pronof in Ciudad Juarez as they were growing up. They're in their 50s now. And their grandkids, my grandkids, are in their high school now, or in the oldest one's 30, and so they still carry on, but Barrett and I are just so pleased to be able to share a few minutes with you, and we, like Arnold, like the Terminator, Arnold Schwarzenegger would say, we'll be back if you want us.
Yes, of course.
And I apologize for not. I've had cancer problems. I apologize for not just being able to get in my car. I don't drive anymore, but have someone drive me down to the beautiful city of Chihuahua, Ciudad Chihuahua, and see your beautiful church, the cathedral, and visit the campus. I was down there in the 1980s. I was there in 1968 to go to Mexico City. I was hosted by when they had the Olympic Games, and I've been isolated in the city of Puebla during a student revolt down
Really?
there. And the army was in there exterminating students at that time. And so it wasn't good. I've seen these things. And so I have great sympathy and love for your great republic and your history. You'll notice in one chapter, I just go into history, starting with Alvar Nunez Cabeza de Vaca and going all the way through President Benito Juarez and President Porfirio Diaz, and show how things have changed over the decades. And then I'm really hoping that the next, and I'm so pleased of the dedication of you and your students, and I can just wish you Godspeed and vaya con Dios.
Well, we are out of time. With this, we will finish this webinar. Professor Hawley, thanks again. This has been an honor and a privilege. I will send you the recognition certificate by email. And
Yeah.
with this, we conclude this.
And
this
if
conference.
any of you wish to get this material, I can email it to you. Other questions. My email is available to you, and just contact me. And
Okay.
If I'm still alive.
Okay. Well, we thank everyone for attending, and see you next time.
Muchas gracias.
Muchas gracias. Hasta luego.
Yeah.